In this video, we're going to find the values of the 6 trigonometric functions of a given right triangle with 2 of its sides and a given angle theta. So here we've got the triangle with angle theta, h as the hypotenuse, and a as one of the sides that's the leg to the right angle. Since this is a right triangle, we can easily find the missing third side by using the Pythagorean theorem. Let's call that side B. Now let's start going through all 6 trig functions now that we have all 3 values for the sides of this triangle. Here are the 6 trig functions that we're trying to find the values of given this triangle and the angle theta inside. Sine of theta is equal to the length of the opposite side of theta over the hypotenuse. So here we would have a over h. Cosine of theta is the length of the adjacent side of theta over the hypotenuse. Tangent of theta is the opposite side over the adjacent side. So here we would have a over b. Next we have cotangent, which is the reciprocal of tangent. So in this case, cotangent would be b over a, meaning the adjacent side over the opposite side. Next we have cosecant of theta, which is the reciprocal of sine of theta. So that means we have the hypotenuse over the opposite side. Finally, we have secant of theta, which hopefully you've guessed by now is the reciprocal to cosine of theta. So here we have the hypotenuse over the adjacent side. In this case, we have the hypotenuse over side B. Now let's take a look at this example. Notice that we don't have the side length of the hypotenuse. If you do the Pythagorean theorem, you should find out that this value should be 4 root 5. After figuring out the length of all 3 sides, we can start with our first trig function. Let's start with sine of theta. Sine of theta, if you remember from the previous slide, is the opposite over the hypotenuse. So in this case, remember that the opposite of theta is the side length 8. So we're going to put that over 4 root 5. At this point, you should simplify this fraction, and also don't forget to rationalize the denominator. Hopefully now you've gotten to 2 root 5 over 5. Don't forget to rationalize the denominator. Let's move on to cosine of theta. Remember that cosine of theta is the adjacent over the hypotenuse. So we'll take the adjacent side to theta, which is 4. And then the hypotenuse, again, is 4 root 5. Doing your scratch work and rationalizing the denominator, you should get root 5 over 5. Next we have tangent of theta. That is going to be the opposite side over the adjacent side. In this case, 8 over 4. Let's do the simplification now, and it's just going to be 2. Let's move on to cotangent of theta. That one's going to be now the reciprocal of tangent. So you could think 4 over 8, or just put the 2 under 1. So let me write that out. Let's go on to cosecant next. And cosecant, remember, is the reciprocal of sine. So that means we can flip the fraction from sine of theta. We'll get 4 root 5 over 8. Remember, by definition, cosecant of theta is the hypotenuse over the opposite side. So that should match up with our triangle to the left. Now once you simplify, you should get root 5 over 2. Finally, we have secant of theta. And secant of theta, by definition, is the hypotenuse over the adjacent side. Pretty much just the reciprocal of cosine. Notice here that our fraction is just the reciprocal of cosine. Once you simplify that, you should just get root 5. And that's how you find all 6 trig functions for a given triangle. Now let's go on to an example you should try. Now it's your turn. Go ahead and try these examples and bring them into class.